Hi everyone, thank you for joining us today. My name is Kevin Weiner and I will be the moderator on this webinar. I'm excited to be joined today by Peter Barron, a technical sales engineer at Airbus Defence and Space, as well as Joe Peters, a solutions engineer at Exelis Visual Information Solutions. During the discussion today, Peter and Joe will cover how the Exelis and Airbus Defence and Space partnership enables ENVI image analysis software users to seamlessly access the Airbus DS catalog of satellite imagery. With quick access to high-quality Airbus DS data combined with powerful ENVI analytics, ENVI users have more time for mission and project planning and can make better decisions. If you have any questions at any point during the webinar, feel free to use the question area of your GoToWebinar dashboard. Peter and Joe will try to address as many questions as they can at the end of the webinar, and if they don't get to your question, they will follow up with you. First, I'd like to talk about the agenda. Today, we're going to go through the Airbus DS catalog extension in ENVI, image preprocessing and analysis in ENVI, some case studies using optical and radar imagery, and then discuss how ENVI users can get free Airbus DS imagery. Before I turn things over to Peter and Joe, we're going to start the webinar out with a poll question so that Peter and Joe have a sense for the type of data attendees are using. So if you can, please tell us what type of data you purchased the most. Optical, radar, aerial, LiDAR, or none of the above. We'll give everyone a few seconds to vote. I see a bunch of results coming in. We'll give everyone maybe 5 more seconds to register their vote. All right, so let's hit close right now. Let's see. So it looks like 72% of you said that you're using optical data. A few percent, 6% said radar, 6% said aerial, and 6% said LiDAR, and 11% said none of the above. It's very interesting, so that's good. With that, I'm going to turn things over to our first speaker, Peter.
All right, Peter, we're going to pass the presentation over to you.
All right, thank you, Kevin and Joe. All right, thank you. And welcome everyone to our first episode of our Exelis, Airbus, and Defense and Space webinar series. The title of today's webinar is Modernize, the Way Data is Discovered. Hopefully, by the end of this presentation, you will have a better understanding of the Airbus Defense and Space satellite products and services and how the data can be easily accessed and analyzed within Exelis analyst software called ENVI, or ENVI as we call it. Before we start showing you some of the great things you can do with the imagery in the software, we would like to give you a brief overview of each company. Let's get started with a quick Airbus introduction. I'm sure many of you have been on an Airbus aircraft. However, we don't just make things fly at 35,000 feet. The Airbus group is made up of 3 divisions. The first division, simply called Airbus, manufactures passenger, freight, transport aircraft and is the division that most people associate with the Airbus name. More than 6,000 commercial Airbus planes are currently in operation around the globe today. The second division, Airbus Helicopters, pretty self-explanatory. They make helicopters. Airbus Helicopters' range of civil and military helicopters is the world's largest. Its aircraft account for 1/3 of the worldwide civil and public fleet. And then we have the third division called Airbus Defence and Space. We build, launch, and manage satellites and ultimately use them for communications and Geo Intelligence activities. The discussion today centers around the Earth imaging satellite products provided by the Geo Intelligence program line of Airbus Defence and Space. Some of you have known us as Spot Image, or Infoterra, or Astrium, before we were rebranded as Airbus Defence and Space Geo Intelligence earlier this year in January 2014. Today, Airbus Defence and Space Geo Intelligence is one of the leading providers of geospatial information from Earth observation satellites. Our core competencies include satellite imagery and tasking, advanced imaging processing of orthomosaics and digital elevation models, and the management of big geospatial data. Basically, we provide a full suite of geographic products and solutions to help boost your imagery intelligence. Starting with satellite imagery, we offer commercial access to the most advanced optical and radar satellite constellations. Based on 30 years of experience in satellite tasking for military, civil, government, and commercial customers, our success in collecting imagery lies in a team of world-class tasking experts to make sure your area is covered on time and in spec. And for those of you who don't require a fresh image, we have over 100 billion square kilometers of satellite imagery in our archive dating back to 1986. Next in our product portfolio, we deliver the most extensive range of orthomosaic and digital elevation models on the market. For instance, the SpotMaps orthomosaic products are truly in the class of their own. This true color base map offers high accuracy coverage across entire national and regional territories at 1.5 meter resolution. This homogeneous reference map is available off the shelf from many countries, ready to integrate into your geographic information systems. To sum up the portfolio, our flexible options regarding data access and delivery enable our clients to make informed decisions in a timely manner, especially when it comes to monitoring and surveillance services. Our network of over 40 direct receiving stations around the world allows us to collect and downlink imagery rapidly on a global basis. And finally, we have a decade of experience providing geospatial data management services and advanced imaging processing capabilities. So, you may be wondering, how are we able to deliver all of this geo intelligence? Well, Airbus DS has one of the most versatile commercial satellite imaging constellations in the business. Some refer to us as a unique one-stop shop for multi-source, multi-resolution imagery. The following charts showcase our broad offering of imagery and reference layers, which are the foundation of our products and services portfolio. Starting with optical, we offer imagery ranging from a half-meter Pleiad to 1.5 meter spot products, all the way to 22 meter Deimos 1 and DMC2 products. A few noteworthy comments on Pleiad and spot satellites before moving on. Together, the two identical Pleiad 1A and 1B satellites, along with the two identical Spot 6 and 7 satellites, form an Earth observation constellation with highly responsive sensors. Because all four satellites operate as a constellation on the same orbit, phased 90 degrees from each other, this space segment brings daily revisit capacity over wide areas in high and very high resolutions over any point on the globe. Furthermore, the tasking plan for each satellite is managed through a single interface, resulting in an optimized collection strategy. All four of these satellites also have the ability to acquire imagery in stereoscopic mode and even tri-stereo mode over large areas, taking advantage of Pleiad's 20-kilometer swath and Spot's 60-kilometer swath size. Tri-stereo can be especially useful over mountainous areas to raise altitude, reliability, and accuracy, in addition to urban areas for accurate 3D modeling. The last item to mention is the spectral advantage of the 12-bit resolution of Pleiad and Spot data. The 12-bit depth maintains absolute radiometric accuracy and offers the full dynamic spectral range of all four bands: red, green, blue, and near infrared. For those of you that use imagery products for spectral analysis, such as calculating vegetative indices or supervised, unsupervised classification or object-oriented approaches, you will receive a greater fidelity to identify the trends and or features that you're looking for. Moving on to our synthetic aperture radar, we can propose our TerraSAR X and Tandem X radar constellation. The TerraSAR X constellation, as we refer to it, acquires data sets ranging from very high to extremely wide area coverage. Our radar products are available from a 1/4 meter resolution acquired from the staring spotlight image mode all the way to 40 meter resolution acquired from the wide scan SAR image mode. For those of you not familiar with SAR, one of the best advantages of radar is the ability to acquire imagery independent of weather and daylight conditions, which means these sensors can penetrate clouds and even image at night. Unlike optical sensors, which rely on reflected sunlight, radar uses their own energy source. TerraSAR X carries a high-frequency X-band SAR sensor, which has a unique agility, rapidly switching between these various imaging modes and polarizations in order to meet the requirements of versatile applications such as hydrological and agricultural mapping, ship, iceberg, oil spill detection, and surface movement monitoring projects, to name a few. The third sat in the list will be PAWS. PAWS will be an add-on to our existing radar constellation, but it will come equipped with an automatic identification system, or AIS capabilities, which is ideally suited for maritime monitoring. The addition of PAWS will provide improved levels of responsiveness and acquisition opportunities worldwide. And finally, we have our reference layers. The satellite assets above allow us to produce a diverse range of products in the third dimension. Customers can choose from a large selection of our digital elevation models derived from both radar and optical sensors. Of note is our state-of-the-art World DEM product derived from the interferometric radar imagery stack. This is the first seamless elevation product covering the entire Earth's landmass pole to pole with unprecedented accuracy and quality. World DEM will offer a DEM with a 12-meter post spacing and a relative vertical accuracy of about 2 meters and an absolute horizontal accuracy of about 10 meters. Radar is also a very unique geolocation accuracy, or it also offers a very unique geolocation accuracy. TerraSAR-X imagery can also be used to generate highly accurate ground control points, typically below 1 meter and in some cases down to centimeters, without any additional ground truth information. This type of product can be valuable for projects where collecting GCPs on the ground is problematic due to weather or difficult access. Now, how can we make use of all this data and provide value for our customers? That brings us to our partnership with Exelis Viz. I would now like to hand off the baton to Joe.
Thanks, Peter. All right, let me just go ahead and get my screen up here. And I'm going to go ahead and start by giving a brief overview of Exelis and where Exelis Visual Information Solutions, which is where we work here in Boulder, Colorado, and ENVI is produced, all comes from. So I'm going to go over the just the basics of our company, and then I'm going to dive into some demonstrations about what we can do with the data that Peter just mentioned in ENVI. And I want to start by saying we're really excited about this burgeoning relationship between Exelis and Airbus Defense and Space. There's some really exciting products that play very nicely with ENVI and the ENVI suite of tools, with the optical imagery, the radar, and especially the digital elevation model products. These are very unique products on the market. And I can't understate how exciting it is to have these products because it really increases the accuracy of remote sensing analysis. By being able to use these digital elevation products to refine the location of remotely sensed imagery on the Earth's surface, we're going to get very accurate results. So it's very exciting. With that said, I'm just going to go over a brief overview of our company. Like I said, our parent company here is Exelis Inc., based out of Herndon, Virginia. Exelis strives to provide next-generation solutions for the communications, intelligence, surveillance, and reconnaissance market. So essentially, Exelis Inc. strives to provide end-to-end solutions for quickly getting information from remote sensing platforms to the people who need the information the most. So we try to provide across-the-board solutions for acquiring the data, cataloging the data, and getting that data, sometimes over very sparse networks where internet connections are slim to none, to the people who need the information the most. Okay. Within Exelis Inc., Exelis Visual Information Solutions falls under the value center, which is Geospatial Systems. Geospatial Systems provides airborne situational awareness, information exploitation. We also build a lot of sensors for satellite and airborne platforms and provide a lot of unique functionality to GPS, and we also do night vision. So we have a wide range of capabilities in image capture, remote sensing, and the navigation industry. And with a legacy of expertise and imagery leadership, this allows Exelis to deliver very specific products for specific needs in the industry. So geospatial systems, as I mentioned, we do all sorts of things with environmental intelligence, geospatial intelligence in the defense and military market, as well as general government contracts. And so some of our sensors and some of our big programs, we have a sensor aboard Swami MPP Veers. We also have a large role in global positioning systems. We have an excellent catalog which is highly optimized, one of the leaders in the industry called Jaguar at capturing and cataloging Jaguar is the name of the product rather, capturing and acquiring full motion video and getting it to the people, essentially federating it across a network. And also ENVI, which is what I'll be talking about mostly within this presentation. So, so drilling a little bit deeper, geospatial systems, Exelis Visual Information Solutions falls under that umbrella. Exelis Visual Information Solutions is based in Boulder, Colorado. We produce a whole suite of software products that are generally geared around what we call the ENVI suite or the ENVI platform. This includes ENVI and IDL. IDL is a programming language upon which ENVI was built. IDL came out of CU Boulder back in the 1970s. It was a highly optimized programming language for analyzing raster data, visualizing data in 3 dimensions, plotting all sorts of graphs and that type of thing. So it lent itself very well to working with raster data and other sources of remotely sensed data. And so what you can think of ENVI as is essentially a gigantic IDL program that is built on top of it. The nice thing about that is anything you can do in the user interface in ENVI, you can do through code in IDL. This allows for a lot of extended functionality with ENVI, including the sharing of extensions that other people have written, as well as batch processing of your satellite or SAR imagery, so as well as LiDAR. And so if you don't have the expertise in-house or you need a little help getting the solution you're looking for, we also have a professional services group that can help with that. So the ENVI platform includes ENVI, ENVI LiDAR, ENVI SARscape for working with SAR and radar data, as well as the ENVI Services Engine, which is our cloud computing architecture, which allows you to essentially federate ENVI across an enterprise or cloud network. And so the next thing I want to talk about is, as part of our partnership with Airbus, we are now providing an extension that was built in conjunction with Airbus Defence and Space, which essentially allows you to view and get information about various different images available in the Airbus Defense and Space catalog. So this is a great tool for allowing you to essentially pull in imagery, just thumbnails of the imagery into the ENVI interface, look at all the metadata that you might be interested in, and begin to kind of get an idea of where imagery might be available for whatever area of interest that you're working with. So this tool is pretty nice because it allows you to pull in these thumbnails. You can look at the thumbnails. You can turn various thumbnails on and off so you can look at different layers. There's also metadata included for each of the files that you pull into ENVI. So there's the sensor that actually obtained the imagery, the resolution of the imagery, the date of capture, the cloud cover, the incidence angle. There's also a metadata URL, which is really nice, as well as an image URL. So you can actually copy these metadata and image URLs into your web browser, and you can go to either the metadata or to a link to the JPEG of the image. And perhaps the most important aspect of this extension is that you can grab the scene ID, so that if you're interested in purchasing that scene from Airbus Defence and Space, you then have the scene ID that they can use to locate that image in their catalog and get it out to you. So this is all great functionality. We're really excited about it. Let me get out of this this slideshow here, and I'm going to show you real quick. I just pulled up on our web page where you can find the Airbus Defense and Space catalog query tool. So essentially, if you're registered with an account on the Exelis Visual Information Solutions webpage, under My Account, which is in the top right corner, you can click on that, and that'll bring you to your account where you can see maybe any quotes and orders you have, any licensing that you have. There's downloads for all of our software, and then the extensions that you'll see right here. And so there's a whole list of extensions in ENVI that allow for just really cool, unique functionality that have been written over the years. And this Airbus Defense and Space is one of them. And essentially, if you wanted to get this into your instance of ENVI, you could just download this .sav file. This is an extension file that can, there's instructions here, but you essentially just put this into your extensions directory in the program files of ENVI. And that would essentially, the next time you kicked off ENVI, you would see that in your extensions folder, and you could open it up and query that catalog. In the interest of time, I'm not going to show that live today, but we're hoping that the next webinar we give, we'll be able to have some time to explore that a little bit more with you. From here, we're gonna move into a bit of a demonstration with Airbus Defense and Space Data in ENVI. So I'm going to start by just loading a spot image and viewing the image in the ENVI display. I just want to take a quick look at the basic visualization tools that are available. And then I want to briefly go over image pre-processing steps for working with Airbus Defense and Space Data from Pleiad and spot sensors in ENVI. Peter might be able to speak to this a little bit more, but there are various different processing levels that you can get when you obtain Airbus imagery. So some of this legwork may already have happened by the time you get the imagery, but it can also be done in ENVI if you so choose. That includes radiometric calibration, which essentially removes any aberrations from the sensor. It corrects for any scan angle variation, and it also removes system noise. You can then perform orthorectification to geocorrect the image so that every pixel in the image represents an accurate location on the surface of the Earth. And then you can also perform atmospheric correction, which removes just any of the noise from the atmosphere, including atmospheric interference. And if you so choose as well, many of these images, depending on how you purchase it, you can actually purchase a pan-sharpened image, which will essentially marry the panchromatic band of the sensor with the multispectral bands to get a crisper image with better pixel resolution. So you can get that directly from Airbus, but if you choose, you can also get the raw data, and you can pan-sharpen it in ENVI using one of a number of algorithms. The one thing I want to say is that in image analysis, sometimes it's nice to get the most raw data that you can, because the more raw the data is, the more flexibility you have in working with it in ENVI. You know exactly what you're doing to the data, and you can kind of step through the process yourself. And then you're essentially doing that work yourself so you can get the most out of the data. So for instance, with multispectral image analysis, often you don't want to work with pan-sharpened imagery to do any sort of classification or change detection, because you're kind of changing the pixel values a little bit when you do a pan-sharpening algorithm. But that's maybe something we'll talk about in another webinar. So we're also going to very quickly use the raster time series toolset to step through a series of images captured over Suez Harbor throughout a week in 2013 rather. And then we'll perform a quick change detection, and I also want to briefly show the spectral index tool to pick out man-made features. So without further ado, let me get out of this slideshow here, and let's get into ENVI and IDL. And I'm going to point out real quick, under all programs here, there's various different options for opening ENVI. There's a 62-bit version, and then there's also what we call this ENVI for ArcGIS, which is essentially a 32-bit version of ENVI and IDL that comes with a 64-bit installer, so when you install 64-bit ENVI, you're getting this as well. What this allows is it enables some of the functionality with ArcMap, so that's just nice to know about.
And Joe, this is Peter here. Just to chime in, you mentioned the different processing levels that Airbus provides, and basically we do provide two basic processing levels. The primary product, which has just radiometric and geometric corrections and is intended for savvy imagery users that want to control their own orthorectification. And then we also provide an ortho-rectified product, and with the several band combinations to choose from. So you get the panchromatic, the multispectral, a bundle product, which includes both the pan and the MS, or a pan-sharpened product. So yeah, we do provide both.
Cool, thanks, Pete. That is one thing that it has been very nice about working with the Airbus Data is there's all the options that you could possibly want for downloading the data. So it just depends, I guess, on your need or what you're trying to do with it. So if you want a pretty image of an area, they've got that for you, and they've also got the, as Pete mentioned, maybe like a more savvy spectral scientist would want the more raw stuff so they could kind of exploit that information themselves. So. All right, so what I'm going to do here is actually I'm going to show the file structure. This is, I believe, what they would call the primary bundle. So this is the multispectral and panchromatic images, not yet orthorectified. So it'll come in a folder like this, and as we drill into it, we can see the multispectral folder as well as the panchromatic. And ENVI can natively just open these files, so I'm going to point out just some of the basics of the things that you'll see here. Number one, you'll see the TIFF file, and so this TIFF file is the actual image, and you can see this is the largest file in the folder. There's also a couple of XML files here. There's the RPC file, which contains information that will help you ortho-rectify the image if you choose. And then there's also this dim .xml file. And this file path, as Peter kind of pointed out to me a couple of weeks back, this contains all the metadata information about the particular sensor, whether it's panchromatic or multispectral, and the date, I believe, down to the seconds. Is that right, Peter?
Down to the millisecond. Yeah, it'll tell you it'll tell you the satellite, the processing level, as well as the imaging date and time of acquisition, as well as the job ID and the processing level.
Cool. So in ENVI, there's a few ways that we can open files. Number one, there's you could just do file open. ENVI recognizes natively many different file formats, and definitely the Airbus included. But if you want to drill in a little more thoroughly, you could just go to our spot images here and open that DIM file this way, or if you're working with their Pleiad sensor, you could do that here as well, and then we've also got some radar options as well. But what I'm going to do is just take advantage of some of the functionality that ENVI has to allow us to open that image just by dragging and dropping it. So ENVI just automatically recognized this XML file, which within this XML file is all the metadata it needs to read this TIFF file. So it's essentially pointing to the TIFF file and then reading a bunch of additional metadata that ENVI can use to display it properly, and also that metadata included in here will help us radiometrically calibrate the image because it contains gain and offset values for the image. So here's our scene that we're looking at. This is Suez Harbor. So we got a beautiful scene here. This is spot imagery. If we want to take a look, we can view the metadata so we can get an idea of the coordinate system that we're working with, the extents of the image, and then also we should have somewhere in here the pixel size.
Yeah, I believe that's a Pleiad image, Joe, right?
You might be right. Oh yeah, you're right, because that's what it said in the metadata, and there it is right there. Pleiad.
Yeah, the PHR in the file name designates Pleiad high res.
So there's our image, and we can do a lot of stuff right off the bat to visualize this image very quickly. So we've got a number of out-of-the-box stretching tools that you can use. So there's a 5% linear stretch applied to the image, and that essentially just takes all of the information from the histograms of the image and applies a 5% stretch. There's an optimized linear, there's a 2%, and then we can also choose to stretch on either the whole image or just the view extent. So that'll essentially compute the histogram information for just the view extent and allow us to change that based on what we're looking at. So this is nice when we have an image with a lot of variation. We can kind of hone in on what we're most interested in looking at and get the appropriate stretch for visualization. So here I'm going to also show there's a bunch of things we can do with the bands that are available. So we've got this near infrared band. So if I wanted to load a color infrared image of the scene, I could load that right on top of the image, which is pretty nice. And now we can see vegetation picked out very nicely because we're using the information in that near infrared band. If I chose to, I could also maybe I wanted to kind of peer through the infrared band to the one below. I can turn the layers on and off, or I've got a number of tools here for punching through. So one of the ones I like to use is this this portal viewer that allows me to punch through. The other thing that we can do in ENVI that's pretty nice is we can also create any sort of view that we want. So there's all these different options for creating multiple views within ENVI. I'm going to go ahead here and show off real quickly. I ran, after doing all the necessary pre-processing steps, I generated this NN diffuse. Oh, I don't want to open you a notepad. I generated this pan-sharpened image, which is the higher resolution, and we can actually see the difference. And so I can actually link my views if I choose. And so this will link all the views so that we're looking at the same geographic extent in both images. Well, it seems to be having a little trouble reading the geographic location, but you can see how the pan-sharpened image is much sharper. And so this is a pretty cool tool. It seems to be misrepresenting the area, but you get the idea of how this would work. So I think it has something to do with the pixel sizes being a little off here. But I'm going to go ahead and now kind of start talking a little bit about the essentially the pre-processing steps and where you can find that information. So if you go into the toolbox here, here's our radiometric calibration tool. This is very simple and straightforward. This would be kind of the first step. So you can select your image, click OK, and then you can choose whether you want to calculate either surface radiance or top of atmosphere reflectance. Just choose your output file name, and ENVI will do the rest using the offset and gain information contained in that dim.xml file. Next on the list would be OrthoRectification. And so OrthoRectification, as I mentioned, this is what ties the pixels to an actual ground location. This is one of the interesting things about the availability of data from Airbus is here I have my input file, and you'll see this DEM file. This is a default digital elevation model file that ENVI ships with that allows you to orthorectify the image using the information in this digital elevation model. I'll say right off the bat, this DEM file that comes by default with ENVI is fairly coarse. It ships with a product, and it's just meant to be a solution if you don't have a digital elevation model with higher accuracy over your area. It'll give you pretty good results. But with the elevation products available from Airbus, you can get really great results. And so that'll improve the accuracy of every given pixel in the image by having a higher resolution digital elevation model available. So you can choose that yourself, or you can just go with the default. If we click next here, in our next screen, you'll see there's options for adding ground control points. And again, this is something that is available from Airbus Defense and Space, which I think is great. They provide ground control points for you, which will allow you to increase the accuracy even more of the orthorectification. So there's some additional information here, but essentially after that, you just go ahead and export your file, and you'd have your orthorectified image. And if you so choose, there are a number of atmospheric correction options available in ENVI. So if you so choose, especially if you're doing a scientific analysis of multiple images of the same area throughout time, you'd really want to perform either flash atmospheric correction or the quick atmospheric correction to make sure that each pixel in each image is accurately representing the whatever surface it is showing. So the last thing I want to mention here is in this example that I'm showing, I'm actually taking a look at this Suez Harbor, where we've got I believe it's 10 images that were shot throughout the course of, I believe it was like a 2 or 3 week period back in 2013. Now, I could step through each of these processes that I just showed, the OrthoRectification and the Radiometric Calibration, individually. So I could go through those workflows for each image file. Or with the extensibility with IDL that ENVI provides, we can actually just have ENVI do the work. And so here's a simple example of batch code using what we call an ENVI task, which provides functionality for doing these sorts of things in a very easy, human-readable way. This is the kind of code that you don't have to be scared of. It's really designed for not necessarily computer programmers so much as maybe just a GIS user or someone who's just working with imagery. It's very easy to follow. It's very human-readable. So essentially here's our orthorectification batch module. So all the information you saw in that workflow is being asked for here, and then you just go ahead and compile and run it. So basically I've said here all the files that are in this subdirectory I want you to run the process on. This is the digital elevation model I want you to use. This is what I want you to do. And this is where I want you to put the results. So I just went ahead and ran this on all 10 images, and ENVI just did the work. I went and got lunch, and when I came back, I had my orthorectification complete. So one of the ways I'm going to show you these images here is we have these time series tools built into ENVI. So essentially you can pull your images into ENVI and build this time series file. And I just dragged and dropped that into ENVI. And you'll see this series manager popped up. So now I have all of these files are now loaded into the time series tool, and I can step through them individually and look at changes. And so in this specific example, I'm kind of interested in seeing how these ships come and go. So you can see that the ships come and go at various different rates. You can see the date and time here. I like that, but I want to see that bigger. So why don't I go ahead and choose to annotate this and select date and time.
Yeah, Joe, and I think this particular series we acquired about 8 images over 8 consecutive days. So this shows the daily activity in this harbor.
Cool. Okay, and so I'm going to go ahead and just kind of play through that, and you'll see I've chosen no delay, but I can choose you know, the delay. You're seeing a little bit of delay. The webinar likes to gum up the works when I do these presentations live. But you can see that you can kind of step through the imagery. You can pause at any point. You can add additional annotation. We've also got these feature counting tools in ENVI that would allow us to say select a feature. Like let's say we're interested in cruise liners. I could go ahead and feature count all the cruise liners that are in the image. And just like that, I could pop this up. These are exportable. exportable to shapefile in various different formats. If I really wanted to break up my scene, I could add a grid, which would allow me to examine each grid individually so that I could break it up into a more manageable workflow. So these are just methods for doing somewhat of a literal analysis of the scene, where I'm not using the automatic analytic tools, which ENVI is very good at, but it's just something that you might want to do with an image to kind of play through it. The other thing that's nice about this is any of the images in the time series tool, I can actually export. So I can take the current image and I can load that raster into ENVI, and that'll pop it up in the image display, and then I can do further analysis on it. So that's a nice thing. So with that said, let's go ahead and load up. I basically wanted to take a couple of these images and just step through an image change workflow. Let's see. So here's two of these images that I thought showed some interesting changes to these ships here. So you can see I can adjust the transparency to see one then the other. You can see various different changes. You can see that even with the OrthoRectification, there are subtle differences in the pixel locations. If we had a higher resolution digital elevation model, or maybe ground control points, we could get that more accurate. But in our change detection workflow, we're actually going to take care of that by registering the images so each pixel value lines up a little bit better. So I'm going to go ahead and open my image change workflow. That's going to prompt me to choose a time 1 file, choose a time 2 file, and then I'm just going to click next. I'm going to go ahead and register the images automatically. So ENVI is going to just go ahead and use, you can select the band that you use. I'll just choose the defaults for now. It's going to select a number of tie points. It's going to eliminate any errors, and it's going to go ahead and do that. Okay, and I'm going to perform an image difference. Because we're looking at features over water, I'm actually going to use one of these feature indexes. I'm going to look at the water index. So we'll see where water has kind of disappeared from the image, which in this circumstance would be where a boat has come or gone in the image. So I'm going to go ahead and click next, and that's going to compute a change image for us. So here we see areas of blue, areas of red show where boats have come and gone. I'm going to go ahead, and you can see how there's some kind of background noise in various different places. Where change hasn't really happened, it's just the pixel values have changed slightly. So I'm going to apply thresholding to essentially eliminate that noise. There's various different methods for doing this. You can also do it manually. When you do it manually, you're going to get pretty good results, but I'm just going to go ahead and for this demonstration choose, I want to look at both increase and decrease, and I'm going to choose this Atsu's method for thresholding, which is an algorithm that will essentially do the thresholding for me. Okay, and so we can do a little cleanup here, some aggregation, some smoothing of the outputs. I'm going to click next. And we can export vectors in various different formats, including shapefile. But for this presentation, I'm just going to go ahead and export a class image, which is just an image classification in ENVI. Go ahead and choose the default, and then when that's complete, that will load into the ENVI interface. And here we can see where changes have occurred in the image. So this is a great way. You can see it did pick up some pixel values around here. If I had done some manual cleanup, I probably could eliminate that. And you can see where boats have come and gone in the image as picked out for us. So that's a brief overview of some of the neat things that can be done with automated change detection in ENVI. The next thing I'm going to show here, just the last thing I want to show real quickly, is in ENVI 5.2, which came out about a month ago now, we've added a number of spectral indices. So we've always had the capabilities of computing these ourselves. We've just kind of cleaned up that process and added a number of them for you. So I'm going to go ahead and choose the input raster that I want. And then we've got this whole list of available indices, and what these indices essentially do is they take the available bands in any given image. So if you're working with a hyperspectral image or a multispectral image, the more bands you have, the more choices you're going to have for these indices. But for this example, since there's not a lot of, there's a ton of, in the scientific literature, there's a ton of vegetation indices. And I'm hoping that in a future webinar we can show some precision agriculture applications for this type of thing. But since we're over Suez Harbor here, it's not exactly a highly vegetated area. I'm going to choose this iron oxide index, which will essentially compute the iron oxide content, which correlates very nicely to built-up features and man-made features in the image. So I'm going to go ahead and click OK, let that compute, and get my result. And so you'll see our result here is that took a couple of the bands in the image, did some band math on it, and essentially extracted the built-up features by making them brighter pixels in a grayscale image. And now we can threshold that using our raster color slice tool. So rather than just work with a grayscale image, let's actually get that information out. And so you can see here this just brought up a color palette. It applied that color palette to the image. By default, it automatically stretches across the entire histogram. But I want to kind of narrow that down a bit. So let's say I make that 0.5 and this something like 1.4, and you can always play with this and select a different color table if you'd like. I'm going to go ahead and just keep 16 slices and have them stretch across these values in the histogram. And you can see we've now essentially kind of sliced that image into various different components. And so you can see that, you know, iron oxide content, as we would expect, is very high on these shipping vessels, as well as around the stadium and anywhere that man-made features are present in the image. And so we can do various things with this. We can export to a class image, or we can export to a shapefile. And so if I had the 32-bit version open, which is interoperable with ArcMap, I could then even push this information directly into ArcMap and continue my analysis or my visualization in that product. So I think that's about all I have for what I wanted to show off. I'm going to go ahead and pass it back over to Peter, and he's going to show you one more cool example of some of the neat things that they're doing with their imagery.
Great stuff, Joe. I really love some of the features in the new version of ENVI 5.2. This is exactly why we at Airbus are so thrilled to be working with Exelis. Next, we would like to move on to a quick case study that talks about the advantages of using both optical and radar. Let me just share my screen here. There we go. In some cases, not just one kind of sensor can answer all your questions. That's why mixing the sensors can be valuable for the most effective and comprehensive surveillance. So when it comes to resolution, Airbus DS has the capacity to mix both optical and radar data with various resolutions to help expose the full picture. If you need more frequency, give us a call. Using the highest resolution imagery all the time can have serious budget and time constraints for certain projects. Collection times could be much longer if you were to rely on very high resolution imagery to monitor large areas all the time. That's why leveraging different sensors may afford better revisit times and different passing times. While our optical sensors image between approximately 10 to 11 a.m. local time, our radar sensors are capable of imaging both in the morning and the evening. If you want more coverage, mixing the sensors also enables high data acquisition reliability through sensor redundancies. For instance, some of our clients use SPOT to capture a regional snapshot while focusing in areas of high interest with high resolution for daily surveillance. And when it comes to detection and identification, simply put, radar can see where and when optical data cannot due to the cloud and daylight independence. Radar is really a measuring system for easily identifying changes on the Earth's surface. So how does all this work in a real life scenario? Let's look at a case study over Crimea. Zooming in to the Crimean Peninsula on the Black Sea, excuse me. When there was political unrest in this region and when it escalated to a crisis earlier this year, primarily involving Russia and Ukraine over the control of the Crimean Peninsula, the movements and activities surrounding Sevastopol harbor received a lot of attention. Excuse me. Airbus DS received a call to activate our satellite constellations. Here we have a spot image showing its wide area coverage with the 60-kilometer swath. Next we have a Pleiad image providing higher resolution with a 20-kilometer swath. And then we drilled down with our radar TerraSAR-X sensor and captured this 25-centimeter imagery from the staring spotlight mode with the 4-kilometer swath. Drilling down into the 1.5 meter resolution of spot 6 and 7, we're able to classify and measure large ships and tell their general function. Further, SPOT is capable of collecting contiguous segments during the same orbital pass to extend their field of view. SPOT can collect almost 100,000 square kilometers over an area in a single day and repeat that collection every day, unprecedented in the optical world at this kind of resolution. In the maritime domain, this is highly appreciated to help analysts understand patterns and behaviors of small boats over large areas. However, it's difficult to perform additional classification with smaller boats using SPOT. So now looking at this half-meter Pleiad resolution, we can not only classify the smaller boats, but we can also identify the type of vessel, whether it's a frigate, a cruiser, or a patrol boat, because more information is available on the superstructure or the equipment on board the boat. We can also differentiate between a tanker and a cargo, which is not always the case with SPOT. Another element that's interesting with Pleiad, we can start to understand the activity of the boats by looking at the mooring system in this imagery. If we pay special attention to the number of mooring ropes that are attached to each boat, this gives us an idea of whether the boat is likely to spend a significant amount of time at port. If there are 2 mooring ropes attached to the boat, as in here, then it's likely the ship will not move in the next few hours or days. If there's only 1 mooring rope, then the ship is likely to have just arrived or just about to depart. With radar, specifically the staring spotlight mode, the 25 centimeters, we now get access to very high resolution information. The radar detection capacity of this mode turns out to be very efficient for identification with an experience that gets closer to the optical one. We also get additional information to complement optical imagery since radar signals interact differently with different types of surfaces. For instance, in this image, looking at this linear feature along the dock here, we can recognize that it's made of metal. Since radar is ideal for detecting metallic features, it's very likely to be a rail for a crane at the end of the dock here. In an optical image, we would not be able to understand these types of ground characteristics or what function it may be for these features. Looking across all the sensors lets us combine the image intelligence results from optical with the additional information from radar, like height information, speed estimation, and precise movements. The layover effect shown here of radar and optical can be very insightful. Here we get a profile of the tall objects like the cranes and the superstructure of the ship, very helpful for recognition and identification. This capacity is especially applicable over harbor-like areas. The last example, we're looking at a Kara-class cruiser of the Russian Navy fleet. This boat was decommissioned in 2011 but remained docked in the Sevastopol harbor until early March. On March 6, 2014, the Russian military intervention in Ukraine. The Russian soldiers deliberately sunk this ship in an attempt to prevent any Ukrainian Navy ships from gaining access to the Black Sea. Before it sunk, we captured this image showing the high-resolution characteristics of radar recognition to help identify the vessel. The radar image clearly highlights some of the major weapon systems on board, the helicopter pad on the stern, and even the communication antennas and sighting systems. Well, that concludes our imagery and analysis part of the first webinar. But before we conclude, we have some great news. I'd like to now share a promotion that Exelis and Airbus DS just started. We're giving all new customers the opportunity to get free Airbus imagery through a voucher program. This voucher program will offer $1,300 US or 1,000 euros worth of Airbus imagery with any new ENVI license purchase. That includes the purchase of ENVI or ENVI plus IDL or the SARscape license. Customers are free to choose imagery from any of our sensors, including Pleiad, Spot, and TerraStar-X. This is a worldwide promotion that runs through the end of 2015. Both Exelis and Airbus sales teams are available to answer any questions. So this growing partnership between Exelis and Airbus DS is intended to expand the network of channels that make imagery easily accessible to geospatial users. And finally, we'll end with another promotion by giving away some more data. All interested parties are welcome to go to the Airbus DS website to download a free sample over Suez, Egypt, that was used in today's demo that Joe was showing you. Simply follow the URL listed on this slide. There's also several other optical, radar, and elevation sample data sets available on the Airbus DS website to download free of charge. So that brings us to the end of the webinar presentation for today. I would like to open up the floor for any questions that we may have from viewers. Viewers are also welcome to email Joe and I directly if you have any questions. Thank you for joining us today. Kevin, back to you.
Great, thank you, Peter. First, before we get to the questions that have come in, we're going to ask one more poll question, and that is, which topics would you like Exelis and Airbus to cover in more detail in future webinars? So let's open up the poll here. Your choices are optical imagery applications, radar data applications, elevation information and applications, detecting change over time, or extracting features. So if you could go ahead and answer now, we'll give you guys a few more seconds to get your choices in. This could be multiple choice, by the way, so if you have multiple choices, feel free to ask that or put them in there. Great, let's go ahead and close that. We'll share the results there. It seems like we have a lot of interest across the board, so we'll definitely take note of this and maybe the few that scored a little bit higher and try to address these in future webinars. So we've had a lot of good questions come in. One question is, can you perform registration or change detection using imagery from two different sensors with different resolutions? So Joe, I think that one may be more addressed to you.
Okay, yeah, so that's a good question. It's something that comes up quite often. So with change detection, you really need to, you're essentially comparing pixel by pixel whether or not the values have changed in two given images. So you can resample down to the lower resolution image and perform change detection that way, which is completely acceptable and fine. And so in ENVI, actually in ENVI 5.2, we just added something that actually makes that a lot easier. There were ways to do it in the past, but we have something called the regrid raster tool, which will essentially take the two images so long as they're co-registered, and it will create a common grid with a common pixel size for each of the images in the grid. So that'll essentially allow you to then move on to do that type of analysis. So yes, it can be done.
Great. And another question that came in are, what are some other applications for radar data and analysis?
Well, there are several. Specifically, radar data can be used to extract elevation models. So we created our WorldDem product which is a global data set, all acquired from radar. It's very good at monitoring with very precise detail surface movement monitoring. This is especially useful for ship and iceberg and oil detection. So there are several applications for radar, and it's almost endless.
Great, and I'm going to only ask one of the other questions that came in, just in the essence of keeping on track for everybody on time-wise. So the last question that we'll address is, how can we purchase Airbus Imagery?
It's easy. You can visit our website. We have a search and discovery tool called the GeoStore on the Airbus Defense and Space website. This allows you to search the archive, purchase imagery, and even task the satellite, as long as you're a registered user on our GeoStore. Besides that, you could contact one of our resellers, a partner, or our customer service team, and they can help you with your requirements and place an order.
Great. Well, thank you again, everybody, for joining us on the webinar. A recording of the webinar will be available soon on www.excelisviz.com, as well as www.geo-airbusds.com/ENVI. And if you have any additional questions, feel free to reach out to us. You can see the email addresses here on the screen, and we look forward to having you join us on the next webinar. Thank you again, Peter and Joe, for your valuable insight.
Thanks, everyone. Have a great day.
Thank you.